All right, so before I show you example 2, I just want to mention with this particular chapter, most everything in this chapter is going to be involved discrete random variables, meaning things that we can count. We'll start talking about continuous variables in chapter 5. Okay, so just so you have that in the back of your mind. All right, so the other thing I told you is that there are two conditions, or there's kind of not every distribution counts as a probability distribution. So there are two conditions that have to be satisfied in order for something to count as a discrete probability distribution. On a test or something, they'd probably ask you about this. Okay, first condition is that probabilities, all the probabilities have to be between 0 and 1. 0 means it's impossible, and 1 means 100%, means it's absolutely certain. You can't have something that is less than 0. That would mean it's less than impossible, and you can't have something more than 100%, because certain is as high as it can get. And then next condition is that the probabilities have to add up to 1, meaning they have to add up to 100%. Okay, those are the conditions. So I'll give you an example. Let's do a distribution for rolling dice, or I guess rolling a dice. I think dice is the plural. So the way that you usually set one of these up is you have an x column, and then you have a p of x column. Actually, I shouldn't have written it there because you're not going to be able to see it. So let's do it right there. Okay, so the x's represent the outcomes of what could happen when you roll a die. You could get a 1, a 2, a 3, a 4, a 5, or a 6. And then the probability for each one would be, well, there's a 1 in 6 chance that you would get that. I guess I shouldn't use red right there. There's a 1 in 6 chance for that, a 1 in 6 chance for that, and so on, that you would get any one of those things. If you add up 1 6 plus 1 6 plus 1 6 all those times, what are you going to get? You're going to get 100%. So that condition is satisfied. And all of these probabilities, 1 6, well, 1 6 is definitely between 0 and 1. So that's a simple example of a discrete probability distribution. Okay, these are the steps for actually making one. But I think it's easier, rather than going through these steps, it's easier to just watch somebody do one, and then you will know how to do it as well. All right, so here's an example of this is a industrial psychologist, and he is administering a personality test for passive aggressive traits to 150 employees. Okay, so that means if you add up these frequencies right here, you would get 150. It says each person gets a score from 1 to 5. 1 means you're extremely passive, 5 means you're extremely aggressive, and 3 means you're somewhere in the middle. You don't have either. Okay, and the results are in this table right here. Make a probability distribution for the random variable x. Remember, x is the outcome. So the outcome in this experiment is whatever your score was. Okay, so you can see here's our probability distribution right here. Okay, and obviously, normally this should have been covered up, but when you start out this problem, neither of these things are going to be here, and you have to fill in your outcomes, which are the scores 1, 2, 3, 4, 5. And then you have to find your probability. So let's see how to do that. So what's the chance that I pick somebody who has a score of 1? It's going to be 24 out of 150. And when you put that in your calculator, you will get the number that you see there, 0.16. What's the probability that I scored a 2? That would be 33 out of 150. And when you plug that in a calculator, you would get 0.22. You could see that they do the same for scores of 3, 4, and 5. So that's how you do it. Okay, they are telling us then to graph this using a histogram. I'll try and put up another video showing you like actual pictures of the calculator, but for now I'll just tell you what buttons you have to press. So you have to put this data right here in L1, and you'd have to put your frequencies in, I take that back. You put the scores in L1, and you put these probabilities in L2. So the probabilities that you see right here, those go in L2. And then here are the buttons that you press. This is for a TI-84 calculator. So if you press the exact same buttons I'm about to tell you, it will work out. First thing you do is put those numbers in L1 and L2. Okay, then what you do is hit second stat plot. And stat plot is right above it's kind of right where y equals is, in the very top left of your calculator. So second stat plot. You get a page that has a bunch of plots. You probably want to hit the first one. It'll say something like plot. And then it may say on or off. Okay, it doesn't really matter for now. When you get into that screen, you'll have a screen that looks like this. It'll say plot 1, plot 2, and so on. Okay, first thing you want to do is make sure that this is set to on. If it's on off right now, move the arrow over and press equals. Okay, then there's probably going to be something here that says type. You want to, at least on mine, it's on the far right side. It looks like a histogram right here. So you want to put your arrow on that one and press enter. Okay, then below that it's going to ask you about the X list. Oops, my screen is freezing there. X list, you want to put L1 in there, and in order to get L1 you hit second stat button. Stat is kind of right next to the arrows, and you put L1 in there. And then your frequency, there's another place that says FREQ. That means frequency, you need second stat, and you need to put L2 there. Okay, so that's how you set it up. When you have all those things, you go to zoom. Zoom is right at the top, very, very top of the calculator in the middle. And then you want number 9, which says zoom stat. And you should, after pressing those buttons, you should get a histogram, basically a bar graph. And if the next page will ever load, there it is. It's going to look something roughly like this. Obviously, you're probably not going to get these nice number readouts right here, but that's okay. You just want to kind of get a general picture. So if we look at that, we can see, well, it looks like most people tend to be around a score of 3. That's the main idea behind getting the graph, just to see the trend.